Have you ever stared up at the night sky and wondered if we're looking at our original home? Tonight, we're diving into one of the most mind-bending questions in human history. What if everything we think we know about our origins is backwards? What if Earth wasn't humanity's first home, but our second chance? I know what you're thinking. This sounds like pure science fiction, right? But here's the thing that's going to blow your mind. The more we study Mars, the more we discover evidence that makes this wild idea seem less crazy and more possible. We're talking about a planet that once had flowing rivers, vast lakes, and maybe even oceans. A world that could have supported life billions of years before Earth was ready for us. But before we get ahead of ourselves, let me be clear about what we're exploring here. This isn't about proving some conspiracy theory or rewriting textbooks overnight. This is about asking the right questions and following the evidence wherever it leads us. And trust me, where it leads us is absolutely fascinating. So buckle up, because we're about to embark on a journey that spans billions of years and two worlds. By the end of this exploration, you'll never look at Mars the same way again, and you might just question everything you thought you knew about where we come from. When you look at Mars today, it's easy to dismiss it as a dead, frozen wasteland. The images we see from rovers and satellites show us a rust-colored desert covered in dust, battered by radiation with temperatures that would kill you in minutes. It's the kind of place that makes you grateful to be sitting safely here on Earth, watching from billions of miles away. But here's where things get interesting. That barren landscape is hiding secrets that tell a completely different story about Mars's past. And I'm not talking about vague possibilities or wild speculation. I'm talking about hard evidence that's been accumulating for decades. Let's start with the most obvious clue. Water. Not the kind of trace moisture we find in Martian soil today, but massive amounts of liquid water that once flowed across the planet's surface. How do we know this? Because water leaves fingerprints that last for billions of years. Picture this. You're flying over Mars in a spacecraft, looking down at the surface. What you'd see are river valleys that stretch for thousands of kilometers. These aren't random scratches in the rock. They're branching networks that look exactly like river systems here on Earth. They have the same patterns, the same flow characteristics, the same delta formations where rivers once emptied into larger bodies of water. The rovers crawling across Mars's surface have found even more compelling evidence. They've discovered minerals that can only form in the presence of standing water. Not just a little moisture here and there, but stable lakes that existed for thousands, maybe millions of years. These aren't temporary puddles we're talking about. These are environments that could have supported entire ecosystems. One of the most exciting discoveries came from studying sedimentary rock layers. Just like on Earth, these layers tell the story of ancient environments. What they're telling us is that Mars once had the kind of stable, wet conditions where life doesn't just survive, it thrives. But water is just the beginning. For life to really take hold and evolve into something complex, you need more than just H2O. You need the right atmosphere, the right temperature, and sources of energy. And here's where Mars gets really interesting, because it appears to have had all of these things. Scientists have pieced together evidence showing that ancient Mars had a much thicker atmosphere than it does today. Think about what that means. A thicker atmosphere can trap heat, creating a greenhouse effect that keeps a planet warm enough for liquid water to exist on the surface. It can protect life from deadly radiation. It can support weather patterns and seasonal cycles. This wasn't some brief moment in Mars's history either. We're talking about conditions that may have lasted for hundreds of millions of years. That's an enormous window of opportunity for life to not just appear, but to evolve and become more complex. Now, I want you to imagine what Mars might have looked like during this period. Instead of the red desert we see today, picture a world with blue skies and flowing rivers. Imagine vast lakes reflecting sunlight, maybe even shallow seas covering large portions of the planet. Picture clouds forming and moving across the sky, bringing rainfall to nourish whatever life might have been growing on the surface. It's a completely different world from the Mars we know today. And that transformation from a potentially habitable planet to a frozen desert is key to understanding why this question about human origins matters so much. You see, planets aren't static. They change over time, sometimes dramatically. Earth has been relatively stable for billions of years, which is why life here has had such a long, uninterrupted opportunity to evolve. But Mars tells a different story. It's the story of a world that had its chance, but lost it. The evidence suggests that Mars began losing its thick atmosphere relatively early in its history. Without a strong magnetic field to protect it, solar wind gradually stripped away the gases that kept the planet warm and wet. As the atmosphere thinned, the climate cooled. Water began to freeze or evaporate into space. What was once a potentially thriving world slowly transformed into the harsh environment we see today. This is where the timeline becomes crucial. While Mars was losing its habitability, Earth was just getting started. Our planet was still settling into the stable conditions that would eventually make it the perfect home for life. If you were an advanced civilization watching both worlds billions of years ago, Mars would have looked like the better bet in the short term. But Earth would have been the safer long-term investment. Now, here's where we need to shift our thinking about time and evolution. We're used to thinking about human development as something that happened relatively recently on Earth. Modern humans have only been around for a few 100,000 years. Civilization as we know it is only about 10,000 years old. Compared to the age of the universe, we're basically brand new. But what if that's not the whole story? What if the roots of humanity stretch back much further than we realize, to a time when Mars was still habitable and Earth was still finding its footing? This isn't about little green men or flying saucers. This is about the possibility that life, including intelligent life, might have had its first real opportunity to flourish on Mars during those hundreds of millions of years when conditions were right. And if that life eventually found itself on a dying world, what would be the logical next step? The answer is survival. And survival, when your home planet is slowly becoming uninhabitable, means finding a new home. It means looking across the void of space to the neighboring world that's just hitting its prime. It means making the ultimate journey from one planet to another. When we think about this possibility, we have to completely reimagine what human history might look like. Instead of Earth being our birthplace, it becomes our refuge. Instead of being the first chapter of our story, it becomes the second chapter. The place where our ancestors continued their story after leaving their original home behind. This changes everything about how we see ourselves and our place in the solar system. It makes us not just Earthlings, but citizens of a larger cosmic story that spans multiple worlds. It suggests that our restless drive to explore, to build, to solve problems and overcome challenges might not just be human nature, but the inherited wisdom of a species that has already survived one planetary crisis. And here's what's really fascinating about this idea. If it's true, then everything we're doing right now, all our efforts to understand Mars and eventually send humans there, takes on a completely different meaning. We wouldn't be exploring a foreign world. We'd be going home. Think about that for a moment. Going home. Not conquering a new frontier, but returning to a place that might hold the deepest secrets of who we are and where we came from. It's a perspective that transforms everything we thought we knew about exploration and human destiny. But let's pump the brakes for a second. I know what some of you are thinking right now. If humans really lived on Mars billions of years ago, where's the proof? Where are the cities, the tools, the obvious signs that an advanced civilization once called that planet home? It's a fair question, and it gets to the heart of one of the biggest challenges in considering this possibility. The answer lies in something most people don't fully grasp. Time. Not just regular time, but deep time. The kind of time that makes human civilization look like a brief flicker of light in an endless night. We're talking about billions of years, and over that kind of time span, almost everything disappears. Let me put this in perspective for you. Here on Earth, with our thick atmosphere and relatively stable conditions, entire civilizations vanish in just a few thousand years. The Mayan cities were swallowed by jungle. Ancient Roman structures crumbled into dust. Even our most impressive monuments, built from the hardest stone, slowly erode away under wind and weather. Now, imagine what billions of years could do to any traces of civilization on a planet like Mars. Without a protective atmosphere, the surface gets hammered by radiation, solar wind, and micrometeorites every single day. Dust storms that can cover the entire planet scour away exposed surfaces. Temperature swings between day and night, crack rocks through endless cycles of freezing and expanding. Over the immense stretch of time we're talking about, even massive structures could be ground down to nothing more than dust in the wind. What we might be looking for isn't grand pyramids or gleaming cities. It might be subtle geological anomalies, chemical signatures in rocks, or patterns that only make sense when you know what to look for. And here's something that might surprise you. We've barely scratched the surface of Mars exploration. Despite all our rovers and orbiters, we've examined maybe 1% of the planet up close. Most of Mars remains as mysterious today as it was 50 years ago. If there are traces of an ancient civilization, they could be sitting in regions we've never visited, or buried beneath layers of sediment that have accumulated over eons. But let's consider another possibility entirely. What if the evidence isn't on Mars at all? What if it's right here on Earth, hidden in plain sight? This brings us to one of the most intriguing aspects of this whole question. If humans or their ancestors really did migrate from Mars to Earth, how would such an incredible journey have been possible? And more importantly, what traces might that journey have left behind? There are actually several ways this could have happened, and some of them don't require the kind of advanced technology you might expect. The simplest possibility is something called panspermia. It's the idea that life can travel between planets on chunks of rock blasted into space by asteroid impacts. We know this process is real because we've found Martian meteorites right here on Earth. These rocks were launched into space when massive asteroids slammed into Mars with enough force to send debris flying across the solar system. Some of those chunks of Mars eventually fell to Earth, where scientists have studied them in laboratories. Now, imagine if microscopic life forms were protected inside those rocks, shielded from the deadly radiation of space by layers of stone. Could they survive the journey? Could they arrive on Earth still viable, ready to take root in our oceans and begin the long process of evolution that eventually led to us? The more we learn about extremophile organisms, life forms that thrive in the harshest conditions imaginable, the more plausible this becomes. We found bacteria that can survive in boiling water, in freezing temperatures, in highly radioactive environments, even in the vacuum of space. If any form of life could make the journey from Mars to Earth, it would be these incredibly resilient microorganisms. But there's another possibility that's even more fascinating. What if the migration wasn't accidental at all? What if an advanced Martian civilization, facing the slow death of their world, deliberately sent life to Earth as a way of preserving their legacy? This wouldn't necessarily require massive spaceships or Hollywood-style technology. It could have been as simple as encoding genetic information into specially designed organisms and launching them toward Earth on natural or artificial trajectories. Over time, those seeded life forms could have evolved on Earth, eventually becoming us, but carrying within their DNA the distant memory of their Martian origins. Think about what this would mean. Every cell in your body, every strand of genetic code that makes you who you are, could be carrying the legacy of another world. We wouldn't be purely Earthborn, but the product of two planets, shaped by the environment of Earth, but rooted in the deeper history of Mars. And here's where things get really interesting. Some researchers have noted puzzling aspects of how quickly life appeared on Earth. As soon as our planet became stable enough to support living organisms, they were already there, thriving in the oceans. That rapid appearance has always been a bit of a mystery. But if life didn't have to start from scratch on Earth, if it arrived already formed from somewhere else, that timeline starts to make perfect sense. There's also the remarkable resilience of life on Earth to consider. Some of the toughest organisms on our planet can survive conditions that seem almost impossibly harsh. They can endure extreme heat, cold, pressure, and radiation levels that would kill most life forms instantly. It's almost as if they evolved to survive not just Earth's conditions, but something much more challenging, something like a journey through space. When we look at human biology itself, there are some curious features that don't quite fit the standard narrative of evolution on Earth. Our bodies seem oddly suited to conditions that don't exist on our planet's surface. We can survive in a much wider range of environments than most Earth species. We're remarkably adaptable, almost as if we were designed to be planetary nomads. Of course, these observations don't prove anything by themselves, but they do suggest that the story of life on Earth might be more complex than we've traditionally believed. They open up the possibility that we're not just the product of one world's evolution, but the continuation of a much older story that began somewhere else entirely. This idea also helps explain some of the enduring mysteries in human culture and mythology. Why do so many ancient civilizations have stories about beings who came from the sky? Why do myths of lost worlds and great migrations appear in cultures that had no contact with each other? Why have humans always felt this deep, inexplicable urge to look up at the stars and wonder if we belong out there? Maybe it's not just curiosity or imagination. Maybe it's memory, buried so deep in our collective consciousness that we've forgotten its source, but not its essence. Maybe when we look up at Mars in the night sky, something inside us recognizes it, even if we can't quite say why. The implications of this possibility extend far beyond just satisfying our curiosity about the past. If humans really did originate on Mars, it changes everything about how we think about our future. It means we've already proven that our species can survive planetary scale environmental changes. It means we've already successfully migrated from one world to another. It means the challenges we face today, from climate change to resource depletion, are not unique or insurmountable obstacles, but part of a much larger pattern that we've navigated before. It also suggests that our drive to reach Mars isn't just about exploration or scientific curiosity. It might be something deeper, more fundamental to who we are as a species. We might be responding to an ancient calling, a genetic memory that's pulling us back to where our story first began. Now, let's talk about what this would mean for our understanding of technology and human development. One of the biggest objections to the Mars origin theory is simple. If an advanced civilization existed on Mars billions of years ago, where are their machines? Where are their tools, their computers, their spacecraft? Surely something that sophisticated would leave traces we could recognize, right? But this assumption might be based on a fundamental misunderstanding of how technology evolves and what survives over cosmic timescales. We tend to imagine that advanced technology must look like our technology, only better. We picture metal and glass and silicon, structures that would be familiar to us, even if they were more sophisticated. What if that's completely wrong? What if truly advanced civilizations develop along paths we can't even imagine? Consider this. Our own technology is rapidly moving away from bulky, permanent structures toward smaller, more efficient, more integrated systems. We're developing materials that are biological rather than mechanical, computers that work more like living organisms than traditional machines. Now, project that trend forward Not just decades or centuries, but hundreds of millions of years. What would technology look like after that much development? It might be so seamlessly integrated with biology that we wouldn't recognize it as artificial at all. It might be made from materials that naturally decompose over time, leaving no trace for future archaeologists to find. Or consider another possibility. Maybe the most advanced technology isn't about building bigger and more complex machines, but about working with natural processes so elegantly that the technology becomes invisible. Maybe a truly sophisticated civilization would leave no footprint because they learned to live in perfect harmony with their environment. There's another factor we need to consider when thinking about Martian technology. Migration between planets would have been an extreme situation, a desperate attempt at survival in the face of planetary collapse. In circumstances like that, you don't pack your whole civilization. You pack the essentials. You take knowledge, genetic material, maybe some basic tools, but you leave the infrastructure behind. Think about human migrations throughout history. When people fled disasters or sought new opportunities, they didn't bring their cities with them. They brought skills, stories, and the determination to rebuild. If our ancestors migrated from Mars, they would have faced the ultimate version of this challenge, starting over on a completely alien world with only what they could carry. This might explain some of the puzzling gaps in human technological development. Why did it take us so long to rediscover certain principles of engineering and science? Maybe we weren't discovering them for the first time. Maybe we were remembering them, slowly reconstructing knowledge that was lost during the Great Migration. It could also explain some of the sudden leaps in human development that have puzzled historians and archaeologists. Why did writing, mathematics, and complex architecture appear so quickly in multiple civilizations around the world? Why do ancient monuments demonstrate engineering capabilities that seem almost impossible given the tools we think those societies possessed? Maybe these weren't innovations at all, but recoveries. Maybe scattered groups of human descendants gradually remembered fragments of much older knowledge, passing it down through generations until someone was finally able to piece together enough information to build something remarkable. This perspective makes human history look very different. Instead of a steady climb from primitive beginnings to modern sophistication, it becomes a story of recovery and rediscovery. We're not the first humans to develop advanced technology. We're the descendants of a much older technological civilization, slowly working our way back to capabilities our ancestors once possessed. But let's step back from speculation and look at what we can actually observe. If Mars was once home to intelligent life, and if some trace of that life made its way to Earth, we should be able to find evidence in the most durable record we have: our DNA. Genetic material is incredibly persistent. It carries information across not just generations, but across geological ages. The DNA in every cell of your body contains a record that stretches back billions of years, encoding the entire history of life on Earth. If that life actually originated somewhere else, the genetic code should contain clues pointing back to those alien origins. And here's where things get really interesting. The more we learn about genetics and evolution, the more questions arise about the standard timeline of life on Earth. Some aspects of our genetic code seem almost too sophisticated to have developed in the time available on our planet. The mechanisms for DNA repair, for protein synthesis, for cellular reproduction are so complex and elegant that they suggest a much longer period of development than Earth's history would allow. There are also some curious anomalies in human genetics that don't quite fit the pattern of evolution from other Earth species. Our brains, for instance, are remarkably overdeveloped for the environments in which they supposedly evolved. We have cognitive capabilities that far exceed what would have been necessary for survival in prehistoric Africa. It's almost as if we inherited neural architecture designed for a very different kind of world. Our immune systems tell a similar story. Humans can adapt to an extraordinary range of diseases and environmental challenges, often much more successfully than other species that have been on Earth far longer than we have. This adaptability suggests a genetic heritage shaped by exposure to conditions much more varied and challenging than anything our planet could provide. But perhaps the most intriguing genetic mystery lies in what scientists call junk DNA. Large portions of the human genome seem to serve no obvious function in our current biology. For years, researchers assumed this was just evolutionary debris, leftover genetic material from our distant past that no longer had any purpose. Recent discoveries have challenged that assumption. Some of this supposedly useless DNA appears to contain complex patterns and information structures that we don't yet understand. It's almost as if our genetic code contains a vast library of information that's not currently being used, but remains available for some unknown future purpose. What if this isn't junk at all, but a genetic time capsule? What if our Martian ancestors encoded crucial information into our DNA, information that would only become accessible once we develop the technology to read and understand it? We might be carrying around the complete history of an alien civilization, just waiting for us to become sophisticated enough to unlock it. This idea sounds like science fiction, but it's actually grounded in solid scientific principles. We already know that DNA can be used to store vast amounts of information. Researchers have successfully encoded books, images, even video files into genetic sequences. If a dying civilization wanted to preserve their knowledge for future generations, embedding it in the genetic code of organisms designed to survive and evolve would be an incredibly elegant solution. The beauty of this approach is that the information would be self-replicating and self-preserving. Every time those organisms reproduced, they would create new copies of the encoded data. The knowledge would spread and multiply, becoming more secure with each generation rather than less. And here's the remarkable part. We might be on the verge of accessing this information right now. Our ability to read and manipulate genetic code is advancing at an exponential pace. We're developing tools that can analyze DNA at levels of detail that were unimaginable just a few years ago. If there really are hidden messages in our genes, we should be able to find them soon. But genetics isn't the only place we might find traces of our Martian origins. There are clues scattered throughout human culture and history that suggest our connection to the red planet goes much deeper than we realize. Consider how Mars has been treated in human mythology and folklore throughout history. Long before we had telescopes powerful enough to study the planet in detail, cultures around the world gave Mars special significance. They named it after gods of war and conflict, recognizing something powerful and important about that reddish dot in the sky. But it goes deeper than that. Many ancient myths speak of beings who came from the sky, of lost worlds destroyed by great catastrophes, of migrations that brought civilization to Earth from somewhere else. These stories appear in cultures that had no contact with each other, suggesting they might reflect some kind of shared memory rather than just imagination. The flood myths found in cultures worldwide are particularly intriguing. Almost every human society has stories about a great deluge that destroyed an earlier world, forcing survivors to start over in a new land. We usually interpret these as references to local disasters like river floods or tsunamis. But what if they're actually cultural memories of something much more dramatic? What if they're remembering the loss of an entire planet to environmental collapse? Human language itself contains some fascinating clues. Words for sky, heaven, and home often share common roots across cultures that developed independently. Our most fundamental concepts about where we come from and where we belong seem to point upward toward the stars, rather than downward toward the earth beneath our feet. Even our basic psychological makeup suggests a connection to something beyond Earth. Humans are remarkably adaptable to new environments, much more so than most Earth species. We seem almost designed to be planetary nomads, comfortable in conditions ranging from Arctic cold to desert heat, from sea level to high altitude. This adaptability makes perfect sense if we're the descendants of a species that successfully migrated between worlds. Our technological development also follows patterns that suggest we might be rediscovering rather than inventing. The speed with which we've developed space travel capabilities, despite having no evolutionary pressure to leave our planet, is remarkable. It's almost as if we instinctively know that reaching other worlds is not just possible, but necessary for our long-term survival. And then there's our relationship with Mars itself. No other planet captures human imagination quite the same way. We've been dreaming about going to Mars, writing stories about Martians, and planning missions to the red planet for over a century. This obsession seems disproportionate to Mars's scientific importance, unless, of course, there's something deeper driving our fascination. Unless we're responding to an ancient connection that we don't consciously remember, but can't quite forget. The timeline of our Mars exploration is particularly interesting. Despite having limited resources and primitive technology compared to what we have today, humans began seriously planning Mars missions almost as soon as we developed the ability to leave Earth's atmosphere. It's as if reaching Mars isn't just a goal for us, but a compulsion, something we have to do regardless of the cost or difficulty. This drive becomes even more significant when you consider that Mars isn't the most logical first target for human space exploration. The moon is much closer and easier to reach. Venus has a thicker atmosphere that could potentially be terraformed. Jupiter's moons might harbor more water and resources than Mars. Yet Mars has always held a special place in our collective imagination and our space program priorities. Maybe that's because deep down, at a level we don't consciously access, we know that Mars isn't just another destination. Maybe we recognize it as the place where our story began. The world we once called home before circumstances forced us to leave and start over somewhere else. This recognition might explain why every image we receive from Mars rovers, every new discovery about the planet's past, feels so significant to us. We're not just learning about an alien world. We might be uncovering our own forgotten history piece by piece, revelation by revelation. And as we stand on the brink of finally sending humans back to Mars, we might be about to complete a journey that began billions of years ago. We might be about to return home. The question of how such an ancient migration could have occurred brings us face to face with one of the most compelling mysteries in this entire puzzle. How do you move an entire species from one planet to another using technology that existed billions of years ago? The answer might be far more elegant and natural than we initially imagined. Let's start with the most straightforward possibility, panspermia. It sounds complicated, but the concept is beautifully simple. Life hitchhikes through space on rocks. We know this process works because we've witnessed it firsthand. Martian meteorites sitting in laboratories around the world prove that chunks of one planet can travel to another and survive the journey intact. Here's how it happens. A massive asteroid slams into Mars with unimaginable force. The impact is so powerful that pieces of the Martian surface get launched into space at speeds high enough to escape the planet's gravity. These rocks tumble through the solar system for millions of years before some of them eventually crash into Earth. Now, imagine microscopic organisms tucked deep inside those rocks, protected by layers of stone from the deadly radiation of space. Could they survive such an incredible journey? The answer appears to be yes. We've discovered bacteria on Earth that can endure conditions so extreme they seem almost supernatural. They thrive in boiling water, survive in frozen wastelands, resist radiation that would kill us instantly, and some can even survive in the vacuum of space itself. If life could travel from Mars to Earth this way, it wouldn't need spacecraft or advanced technology. It would just need time and the natural violence of cosmic impacts. The organisms that made the journey wouldn't have been human as we know ourselves today. They would have been the seeds of life, microscopic pioneers carrying the genetic blueprint that would eventually evolve into us. But there's another possibility that's even more intriguing. What if the transfer wasn't random at all? What if an advanced Martian civilization, recognizing that their world was dying, deliberately engineered this process? They might have created specially designed microorganisms, encoded with genetic information, and launched toward Earth on carefully calculated trajectories. This wouldn't require massive spaceships or energy sources beyond imagination. It would require something far more sophisticated. Biological engineering, the ability to encode information into living systems and trust evolution to carry that information forward across geological time. Think about what this would mean. Every living thing on Earth, from the simplest bacteria to the most complex mammals, might carry within its DNA fragments of information placed there by an alien intelligence. We wouldn't be purely terrestrial life forms. We'd be the products of two worlds, shaped by Earth's environment, but rooted in Martian wisdom. This idea gains credibility when you consider how information-dense DNA actually is. A single strand of genetic material can store more data than the most advanced computer systems we've ever built. If you wanted to preserve the knowledge of an entire civilization, embedding it in self-replicating biological systems would be incredibly efficient. The information would copy itself every time the organisms reproduced, creating an ever-expanding library that could survive almost any catastrophe. And here's what's truly remarkable. We might be on the verge of accessing this hidden information right now. Our ability to read and decode genetic sequences is advancing at a pace that would have seemed impossible just decades ago. We're developing tools that can analyze DNA with precision that borders on the miraculous. If there really are encoded messages in our genes, we should be able to find them within our lifetimes. No, but let's consider an even more dramatic scenario. What if the migration involved actual beings, not just genetic material? What if a Martian civilization developed space travel capabilities and physically transported themselves to Earth? This might sound impossible, but remember that we're talking about a species that had hundreds of millions of years to develop technology while Mars was still habitable. That's an almost incomprehensible amount of time for technological advancement. Consider that human civilization went from horse-drawn carriages to space stations in less than 2 centuries. Imagine what could be accomplished with millions of times more time to develop and refine technology. A civilization with that much time might have developed propulsion systems we can't even conceptualize. They might have mastered energy sources that dwarf anything in our current understanding of physics. They might have created vessels capable of carrying entire populations across the void between planets. The journey itself would have been an incredible undertaking. Even with advanced technology, moving from Mars to Earth would have required careful planning and enormous resources. The travelers would have needed life support systems capable of functioning for years or decades. They would have needed to bring everything necessary to establish a new civilization on an alien world. But here's what makes this scenario plausible. Earth, during this period, wasn't the crowded, complex ecosystem we know today. It was a young world with vast, empty spaces and abundant resources. Early colonists wouldn't have been competing with existing civilizations or complex food webs. They would have been pioneers on a virgin planet, free to establish themselves wherever conditions were most favorable. The settlement process would have been gradual. Small groups might have arrived first, establishing footholds and preparing the way for larger waves of migration. Over time, the Martian presence on Earth would have grown from isolated outposts to thriving communities to a fully established civilization. This gradual process might explain why we don't find obvious archaeological evidence of sudden arrival. The transition from Mars to Earth could have blended seamlessly into the natural flow of evolution and cultural development. What we see as the emergence of human civilization might actually be the culmination of a much older story that began on another world. But whether the migration was biological or technological, gradual or sudden, one thing becomes clear. If humans truly originated on Mars, then our current plans to return there take on profound significance. We're not exploring a foreign world. We're going home. This perspective completely transforms how we think about Mars exploration. Every rover we send, every satellite we launch, every sample we analyze becomes part of a larger journey of rediscovery. We're not just studying planetary geology or searching for signs of ancient life. We're investigating our own origins, piecing together the forgotten chapters of human history. The emotions we feel when we see images from Mars might not just be scientific curiosity or wonder at an alien landscape. They might be recognition, a deep ancestral memory responding to familiar terrain. When we look at Martian sunsets or dust devils or ancient riverbeds, we might be seeing landscapes our ancestors once called home. This also changes how we think about terraforming and planetary engineering. If Mars was once habitable and humans once lived there, then making it habitable again isn't about transforming an alien world to suit our needs. It's about restoration, about bringing a planet back to conditions it once supported. We wouldn't be imposing Earth-like conditions on Mars. We'd be helping Mars return to what it used to be. The technical challenges of Mars colonization also look different through this lens. Instead of trying to adapt Earth-based life to alien conditions, we might be returning to an environment our species once knew intimately. The solutions to living on Mars might not require completely new innovations, but the recovery of old knowledge, the remembering of skills our ancestors once possessed. This could explain why certain aspects of Mars mission planning seem almost intuitive to us. Why do we instinctively know that underground habitats would be safer than surface structures? Why do we immediately recognize that water extraction and atmospheric processing are crucial technologies? Maybe it's because we've solved these problems before. In a time so distant, we've forgotten it consciously, but retained it genetically. The psychological aspects of Mars colonization also become more understandable. Why are so many people willing to volunteer for one-way missions to Mars? Why does the idea of leaving Earth forever to live on a harsh, dangerous world appeal to thousands of potential colonists? Maybe it's because, at some deep level, we don't see it as leaving home. We see it as returning to one. This perspective might also explain some of the remarkable resilience and adaptability that humans demonstrate in extreme environments. Our species has successfully colonized every continent on Earth, from Arctic tundra to tropical rainforest to high-altitude deserts. We adapt to new conditions faster and more completely than almost any other large animal. This flexibility makes perfect sense if we're descended from a species that successfully migrated between entirely different worlds. Our technological development patterns also support this idea. The speed with which we've developed space travel capabilities despite having no obvious evolutionary pressure to leave Earth, is remarkable. It's almost as if we instinctively understand that becoming a spacefaring species isn't just an option for humanity, but a necessity. Maybe that's because we've done it before. Consider how quickly we went from the first powered flight to landing on the moon. Less than 70 years. That's an incredibly compressed timeline for such a massive technological leap. Other major innovations like agriculture or metallurgy took thousands of years to develop and spread. But space technology emerged almost explosively, as if we were remembering how to do something we'd forgotten rather than learning it for the first time. The same pattern appears in our understanding of planetary science and astrobiology. Concepts that should be completely alien to Earth-based life forms, like atmospheric engineering or closed-loop life support systems, seem almost intuitive to us. We develop these technologies not through trial and error, but with a kind of systematic understanding that suggests deeper familiarity. Even our cultural attitudes toward space exploration reflect this pattern. Despite the enormous costs and risks involved, public support for space programs remains remarkably strong. People who will never personally benefit from Mars missions still feel emotionally invested in their success. This widespread enthusiasm for exploring other worlds seems disproportionate unless there's something deeper driving it. Unless we recognize at some unconscious level that reaching other planets isn't just about exploration, but about fulfilling our fundamental nature as a species. The timing of our current Mars exploration efforts also seems significant. We're developing the capability to return to Mars at exactly the moment when Earth is facing its own environmental challenges. Climate change, resource depletion, and ecosystem collapse are forcing us to think seriously about planetary backup plans. It's almost as if we're being pushed to retrace the same path our ancestors might have taken billions of years ago, leaving one world as it becomes less habitable and establishing ourselves on another. This cyclical pattern might be more than coincidence. If human civilization has survived planetary environmental collapse before, we might carry within our collective memory the knowledge of how to do it again. The solutions we're developing for Mars colonization, the technologies we're creating for life support and resource utilization might not be innovations at all, but recoveries of capabilities we once possessed. The genetic engineering and biological adaptation techniques we're researching for Mars missions are particularly intriguing from this perspective. We're learning how to modify human biology to survive in low gravity, high radiation, and thin atmosphere conditions. But what if these aren't new adaptations we're creating? What if we're reactivating genetic capabilities that were once active in our Martian ancestors but became dormant during our long residence on Earth? Recent discoveries in genetics suggest that much of what we call junk DNA might actually be dormant genetic programs, waiting for the right environmental triggers to reactivate. If our ancestors lived on Mars, our genetic code might still contain the blueprints for Mars adaptation, just waiting for us to return to conditions where those traits would be useful again. This idea has profound implications for how we approach Mars colonization. Instead of trying to completely terraform Mars to match Earth conditions, we might focus on reactivating our own dormant Martian genetics. Instead of changing the planet to suit us, we might change ourselves to resuit the planet. Not through artificial genetic modification, but through the recovery of our own ancestral capabilities. The psychological preparation for Mars missions also looks different through this lens. Astronauts training for long-duration Mars missions report that certain aspects of the experience feel surprisingly familiar. The isolation, the confined spaces, the dependence on technology for basic survival, all seem more natural than they should for people who evolved on a planet with abundant air and open spaces. Maybe that's because we didn't evolve entirely on Earth. Maybe we carry within our psychological makeup the mental adaptations necessary for surviving in harsh, enclosed, technology-dependent environments. Maybe the reason some people feel called to become astronauts isn't just individual personality traits, but the expression of ancestral memories encoded in their genes. The dreams and visions that many people report having about Mars are also worth considering. Long before we had detailed images of the Martian surface, humans were describing landscapes that closely match what we now know the planet actually looks like. These dreams often involve a sense of familiarity, of returning to a place that feels like home despite being completely alien to any Earth-based experience. Skeptics would dismiss these as coincidence or subconscious processing of limited available information. But what if there's something more? What if they're genetic memories surfacing in our dreams, fragments of ancestral experience that our conscious minds can't quite access, but our sleeping brains can partially reconstruct? The meditation and consciousness research being conducted in preparation for Mars missions has uncovered some fascinating phenomena. Astronauts practicing extended isolation and sensory deprivation often report experiences that seem to transcend their normal Earth-based awareness. They describe visions of vast landscapes, ancient cities, and technologies that don't exist in our current understanding. These experiences are usually attributed to hallucinations or altered states of consciousness, but they consistently involve themes related to space travel and life on other worlds. What if these aren't hallucinations at all, but memories? What if extended isolation and sensory deprivation create conditions where deeper layers of genetic memory can surface? What if the consciousness techniques being developed for Mars missions are actually methods for accessing our own ancestral experiences? This possibility adds another dimension to the question of why we feel compelled to return to Mars. It's not just about exploration or scientific discovery or even species survival. It might be about completion, about finishing a story that began billions of years ago when our ancestors first looked up at the blue dot of Earth from the surface of Mars and decided to make the ultimate journey. If this is true, then we stand at one of the most significant moments in human history. We're not just preparing to visit another planet. We're preparing to return home after the longest exile in the history of any species. We're about to complete a circle that spans geological ages and connects us to origins we've forgotten but never truly lost. The implications of this possibility extend far beyond space exploration. If humans really originated on Mars, it changes our entire relationship with Earth and our understanding of our place in the universe. We're not just one species among millions that happen to evolve on this particular planet. We're survivors of planetary catastrophe, carriers of ancient wisdom, and proof that life can persist across worlds and through time, scales that dwarf individual existence. This knowledge would transform how we approach the environmental challenges facing Earth today. We would understand that we've survived planetary climate collapse before, that we possess the genetic and cultural heritage necessary to adapt to changing conditions, and that the skills we're developing for Mars colonization might be exactly what we need to preserve life on Earth as well. It would also change how we think about our responsibilities as a species. If we're the inheritors of Martian civilization, we carry the obligation to preserve and continue that legacy. The knowledge and capabilities we're rediscovering through space exploration might not belong just to us, but to the entire history of intelligent life in our solar system. The question of whether humans lived on Mars before Earth may never be definitively answered. The evidence is too ancient, too buried under billions of years of planetary change. But the possibility itself is transformative. It expands our understanding of what it means to be human, of where we came from, and of where we're ultimately headed. As we prepare to send humans back to Mars, we might be about to discover that we're not explorers venturing into the unknown, but descendants finally returning to a world our ancestors once knew. We might be about to come home. The journey back to Mars would represent more than just the culmination of human technological achievement. It would mark the moment when we finally piece together the scattered fragments of our deepest identity. Every step we take on that familiar yet foreign soil might trigger recognition that goes beyond conscious memory, touching something primal in our species' collective soul. Think about what this means for the astronauts who will eventually make that journey. They won't just be explorers or scientists or pioneers. They'll be archaeologists of their own heritage, walking through landscapes that might once have been home to their ancestors. Every rock they examine, every sample they collect, every photograph they take could potentially unlock secrets about who we really are and where we truly come from. The psychological impact of this realization would be staggering. Imagine being the first human to set foot on Mars and suddenly understanding that you're not the first human to walk on that world, that countless generations before you called this place home, that the red dust beneath your feet might contain the remains of civilizations so ancient they predate everything we think we know about human history. This recognition might not come as a sudden revelation, but as a gradual awakening. The first clue might be the way certain geological formations seem inexplicably familiar. The second might be an instinctive understanding of how to navigate the Martian landscape, as if following paths carved into genetic memory rather than maps created by robotic explorers. The technology we develop for Mars missions might start behaving in unexpected ways once we actually reach the planet. Equipment designed for one purpose might prove surprisingly effective at tasks we never anticipated. Life support systems might operate more efficiently than models predicted. Habitat designs might feel more natural and comfortable than they should for structures built to house Earth-evolved humans on an alien world. These wouldn't be coincidences or lucky accidents. They'd be signs that we're working with rather than against our fundamental nature, that the solutions we're creating for Mars survival aren't innovations, but recoveries, that we're not adapting to an alien environment, but readapting to conditions our species once knew intimately. The social dynamics of Mars colonization also take on new significance through this lens. The psychological profiles of people who volunteer for Mars missions reveal interesting patterns. They tend to be individuals who feel somehow displaced on Earth, who experience a deep restlessness that can't be satisfied by terrestrial adventures or achievements. They describe feeling called to Mars in ways they can't fully articulate or explain. Maybe that calling isn't just wanderlust or the appeal of the ultimate adventure. Maybe it's something deeper, more ancient. Maybe certain individuals carry stronger genetic echoes of our Martian heritage, making them more sensitive to the pull of our original home. They might not consciously remember Mars, but their bodies and minds might recognize it as the environment they were originally designed for. The community structures that emerge in Mars colonies might also reflect patterns that seem surprisingly natural for such an artificial environment. Early Mars settlements will necessarily be small, tightly knit communities where every individual's contribution is crucial for collective survival. This social organization might feel familiar, not because it resembles anything from Earth's history, but because it echoes the social structures our Martian ancestors developed to survive in similar conditions. The decision-making processes, the resource allocation systems, the methods for resolving conflicts and maintaining morale in isolated, high-stress environments might all follow patterns that seem intuitive but have no clear precedent in Earth-based societies. These wouldn't be innovations created for Mars conditions. They'd be the reemergence of social technologies our species developed long ago for exactly these circumstances. Language evolution on Mars presents another fascinating possibility. Linguists studying isolated communities have observed that human language adapts remarkably quickly to new environments and circumstances. The vocabulary, grammar, and even pronunciation patterns that emerge in Mars colonies will necessarily be different from Earth languages, shaped by the unique conditions of Martian life. But what if some of these linguistic innovations aren't really innovations at all? What if certain words, phrases, or grammatical structures that develop on Mars actually represent the recovery of linguistic patterns our species used during our original Martian period? What if our brains retain not just genetic memories of Martian life, but linguistic memories as well? The children born on Mars will be particularly interesting from this perspective. They'll be the first humans in billions of years to develop from birth in Martian conditions. Their physical adaptations to low gravity, thin atmosphere, and high radiation will be obvious and measurable. But their psychological and cognitive development might reveal even more profound changes. These children might display intuitive understanding of Martian conditions that their Earth-born parents lack. They might develop problem-solving approaches that seem remarkably sophisticated for individuals with no previous experience of planetary colonization. They might create games, stories, and cultural practices that feel ancient despite being entirely new. Most intriguingly, they might begin to remember things they couldn't possibly know, not through any mystical process, but through the activation of genetic memories that become accessible when the right environmental conditions are present. These wouldn't be detailed historical memories, but impressions, feelings, and instincts that guide behavior in ways that enhance survival and success on Mars. The relationship between Earth and Mars would also evolve in unexpected directions. Instead of Mars remaining forever dependent on Earth for supplies and support, it might begin to offer something back that Earth desperately needs. Not just scientific knowledge or mineral resources, but wisdom. The wisdom of a species that has successfully navigated planetary environmental collapse before. As Earth faces its own climate challenges, the solutions developed on Mars might prove surprisingly applicable to terrestrial problems. Not because the problems are identical, but because the fundamental challenge is the same. How do you maintain complex civilization when planetary conditions become hostile to life? How do you preserve knowledge, culture, and genetic diversity through periods of environmental catastrophe? Mars colonists might rediscover techniques for resource conservation, closed-loop ecosystem management, and long-term planning that could revolutionize how we approach sustainability on Earth. These techniques might seem remarkably sophisticated and effective, not because Mars colonists are more innovative than Earth dwellers, but because their recovering approaches our species perfected during our original Martian period. The exchange between worlds might eventually become bidirectional in ways we can't yet imagine. Earth might provide genetic diversity and cultural innovation, while Mars provides ancient wisdom and survival strategies. The two worlds might become partners in a way that mirrors the original relationship between ancient Mars and young Earth, with life flowing between planets as conditions change and opportunities arise. This partnership could extend beyond just human civilization. The terraforming efforts on Mars might succeed not through brute force engineering, but through the recovery of biological relationships that once existed there. Earth organisms introduced to Mars might thrive in unexpected ways, not because they're adaptable, but because they're returning to conditions their distant ancestors once knew. The timeline for Mars terraforming might accelerate dramatically once we understand that we're not creating new ecosystems, but restoring old ones. The genetic information needed to rebuild Martian life might already exist in Earth's biosphere, carried by organisms whose Martian origins we haven't yet recognized. Instead of spending centuries trying to engineer Earth life to survive on Mars, we might discover that some Earth life is actually Martian life that has been waiting for the right conditions to express its true nature. The discovery of subsurface life on Mars would take on completely different significance in this context. Instead of finding alien organisms that evolved independently, we might find distant cousins of Earth life, species that remained on Mars, while their relatives made the journey to Earth. These organisms might carry genetic information that fills in gaps in our understanding of our own evolutionary history. The medical implications would be enormous. Diseases that affect humans might have their origins in our Martian past, and their cures might be found in Martian organisms that evolved different solutions to the same biological challenges. The genetic diversity of Martian life, even microbial life, might provide keys to treating conditions that have puzzled Earth-based medicine for centuries. The philosophical implications would be even more profound. The discovery that Earth and Mars life share common ancestry would fundamentally change how we understand our place in the universe. We wouldn't be alone in the cosmos, but we wouldn't be in contact with truly alien intelligence either. We'd be part of an extended family of life that spans multiple worlds, connected by bonds that reach back to the earliest history of our solar system. This realization would transform how we approach the search for life elsewhere in the universe. Instead of looking for completely alien forms of life, we might search for other branches of the same cosmic family tree. The techniques we develop for recognizing Martian life might be applicable to detecting life on other worlds that shares the same ancient origins. The space exploration programs of the future might focus not just on discovering new worlds, but on tracing the paths that life has taken throughout the cosmos. Each new planet we explore might hold clues to chapters in our own story that we've forgotten. Each discovery might bring us closer to understanding the full scope of our heritage as a species. The psychological impact on humanity would be transformative. We'd understand ourselves not as isolated inhabitants of a single world, but as participants in a cosmic story that spans geological ages. Our problems and challenges would be placed in a much larger context, making them seem both more significant and more manageable. The knowledge that we've survived planetary catastrophe before would give us confidence that we can do it again. The understanding that we carry within our genes the accumulated wisdom of billions of years of survival would provide hope during our darkest moments. The recognition that we're part of something much larger than ourselves would inspire us to think and act on scales that match the true scope of our heritage. The return to Mars wouldn't mark the end of human exploration, but the beginning of a new chapter in a story that's far older and more complex than we ever imagined. We wouldn't be leaving home to explore the universe. We'd be returning home to prepare for the next phase of a journey that began long before we learned to look up at the stars and wonder what was out there waiting for us. The red planet that has captured our imagination for so long might not be a destination at all, but a way station, a place where we pause to remember who we are, to recover what we've lost, and to prepare for whatever comes next in the cosmic adventure of consciousness, exploring itself through space and time. As we stand on the threshold of that return journey, we might be about to discover that the greatest exploration isn't outward into the unknown, but inward into the forgotten depths of our own nature. The most profound discovery might not be what we find on Mars, but what Mars helps us remember about ourselves. The moment we set foot on Mars again, we might experience something that no amount of training could have prepared us for. Not the low gravity or the thin atmosphere or the alien landscape, but recognition. A feeling of coming home that makes no logical sense but feels more real than anything we've ever experienced. Imagine the first Mars colonist removing their helmet in a pressurized habitat and breathing recycled air that somehow smells familiar. Imagine them looking out through reinforced windows at a sunset that paints the sky in colors they've never seen but somehow remember. Imagine them walking across terrain that their instruments say is completely foreign, but their instincts navigate as if they've traveled these paths before. These wouldn't be mystical experiences or wishful thinking. They might be the first stirrings of genetic memories awakening after billions of years of dormancy. Our DNA doesn't just carry instructions for building proteins and regulating cellular functions. It carries the entire history of our species, including chapters we've forgotten we ever lived. The children born on Mars will be the real test of this theory. They'll develop in conditions no human has experienced for geological ages, if ever. But what if their development follows patterns that seem surprisingly natural for such an unnatural environment? What if they display abilities and instincts that their Earth-born parents lack? These Martian children might instinctively understand how to move efficiently in low gravity. They might show remarkable tolerance for radiation levels that would concern their parents. They might develop social behaviors perfectly suited for small, isolated communities under constant environmental pressure. Most intriguingly, they might begin to display cognitive abilities that seem designed for the specific challenges of Martian life. But the real revelation might come when these children start to dream. Dreams have always been windows into deeper layers of human consciousness, places where memories we don't consciously access can surface and play out in symbolic form. What if Martian children begin dreaming of landscapes and structures and technologies that don't exist in any human database? What if their sleeping minds start reconstructing fragments of experiences their species had billions of years ago? The implications would extend far beyond individual psychology. If human consciousness carries genetic memories of our Martian origins, then everything we think we know about memory, learning, and cultural transmission might need to be reconsidered. We might discover that knowledge doesn't just pass from one generation to the next through teaching and imitation, but through biological inheritance that operates on time scales we never imagined possible. The technology we develop for Mars might start behaving in ways that surprise even its creators. Engineers designing life support systems might find themselves making design choices that seem to come from nowhere, but prove remarkably effective. Architects planning Mars habitats might discover that certain structural arrangements feel intuitively correct, despite having no precedent in Earth-based construction. These wouldn't be accidents or lucky guesses. They might be the expression of genetic memories guiding our hands and minds toward solutions our ancestors discovered long ago. The knowledge wouldn't be conscious or detailed, but it would be real, embedded in the patterns of neural development that evolution preserved through our long exile on Earth. So here we are, standing at the edge of the most profound question humanity has ever faced. Whether we originated on Mars or not, the very act of asking this question changes us. It forces us to think bigger, to imagine longer timelines, to consider possibilities that stretch our understanding of what it means to be human. And maybe that's the real point. Maybe the journey back to Mars isn't just about returning